Hello, my name is Parit Patel, and I decided to do my project on the growth rate of miniaturized plants. I thought of this project while I was at my job on the farm. Every planting season, we encounter up to 20 miniaturized plants during the transplanting process. Miniaturization generally occurs when the roots of these plants get too stressed out during the transplantation process. We generally have been throwing these plants away because they take up the same amount of time and resources as regular plants to grow. However, they don't grow to be nearly as tall as regular plants. For my project, I wanted to find out how much they could actually grow and if it's actually worth it to try and save them in the long run. My data needs were very simple and consisted of taking weekly measurements using a simple ruler of all of the miniaturized plants I set aside. Gathering this data was very simple and easy since I can take care of the plants and collect the data uh, on their heights whenever I go to work. To give them the best chance of survival, I placed all of these plants outside, exposed to all of the elements, and fed them fertilizer and other growth aiding materials to help them grow as much as they could and as fast as they could. My original plan was to test 3 to 5 the healthiest one, but as you'll see from my results, my plan didn't work out this way. For my data classification, my original plan was to store my data in a semi-structured Word document. Instead, I'll be now transferring the data over to a structured Excel file for better organization. As far as the data itself is concerned, I wanted to test this on a variety of plants, but only had 10 tomato plants to be specific to work with. Since I can't ethically force more variety of plants to go into a miniaturized state, I only had these plants to work with. For my storage and archival, I decided that all of my original data will be saved and updated through my Google Drive account. This will help keep it backed up and saved at all times. The final data results will additionally be archived onto the cloud, also on my Google Drive, and locally backed up on my boss's work computer. As I was analyzing the data I collected, I started to realize that saving these plants was just not a viable option. Almost all of the plants succumbed to some sort of illness and died within the first week. The last couple surviving ones ended up dying in their last week. I was gonna present the data in a Word file, but that's just not visually appealing. Instead, I'm going to present the data in two bar graphs to help visualize the growth rate of the plants. Additionally, I'm going to be comparing the tallest miniaturized plants with an average size normal plant. That way we have an idea of the growth difference between the two. Fortunately, my data only contains data pertaining to plants. There is no personal or private information that needs to be secured or censored. I still implemented some security measures just to be safe. I added two-factor authentication on my Google Drive where my data will be stored and archived. And additionally, I'm only accessing this data using a secure PC connected to the internet with a VPN. As you can see from my data, almost all of the plants died within the first week. And the tallest surviving plant only grew to be 1.3 inches that produced no product at all before dying as well. Additionally, the main discovery I made from the data was that miniaturized plants have no immune system to help them once they get sick. This could be anything from rot to fungus to getting burned from too much fertilizer. And my data, as you saw earlier here, proved exactly that because many of them died for fungus within the first week because they no longer have that immune system to fight it off once they get it. Once they get even the smallest bit of fungus spores on them, they don't have any immune system to fight it off, and that fungus will continue to grow without anything holding it back. If it was a normal plant, it would be able to fight off the fungus and continue to grow, and the fungus would be gone before you would even notice it. Unlike these miniaturized plants, that's why almost all of them died of fungus, and they all ended up dying, whether from fungus or some other illness by week 4. So what I learned from this experiment was invaluable for the farm that I work for. This is because we used to try and save these miniaturized plants, but now we know not to waste any time or resources on these plants and just to toss them out once they become miniaturized. Most importantly, we now know miniaturized plants only grow to be less than 2 inches tall, while miniaturized plants average a height of 5 feet, or in another word, 60 inches. So as you can see here, most of the plants grew very little before dying. Almost all of them died within the first week. 2 of them made it to the second week, but one of the 2 died in that second week. And the only one that survived past the second week died in the 4th week. The tallest one that lived only grew to be 1.3 inches, as I mentioned, comparable to the average height of a plant, which is about 5 feet or 60 inches. Additionally, I also inputted this graph to show the difference between the growth rate of a miniaturized plant and a normal plant. As you can see, the normal plant is significantly larger, and they both take up the same amount of resources, time, and money that we have to put into fertilizer and other treatment that we give them. These plants are in fact so small when you compare them to normal plants, it would be financially irresponsible for this farm to spend any time or money on these plants, mostly because they don't produce any product. Since they're only 1.3 inches tall, that's not nearly big enough for them to be able to produce any usable or edible product. Overall, this project may seem like a failure because all of the plants died, and the one that grew the most grew up to be only 1.3 inches, comparable to 60 inches with no produce. However, as I mentioned, this project was hugely beneficial to the farm because we now know not to save any of these miniaturized plants. We used to try to save them and try to put as much work into it as we could until it looked like they just weren't going to make it. But now we know not to even waste that much time or resources into it. As far as the future is concerned, I would like to build onto this project and explore additional measurements that will help benefit the farm. My current plan is to do a similar project on testing out different mixtures of fertilizer and fungicide to determine the most effective combination. And I would like to say a special thanks to Southern Earth Entourage Farm and its community for allowing me to test out these plans and perform my project.